Welcome back to Introductory Statistics, Chapter 1, Section 3. We're going to talk about data types. One of the things that is important to understand early in the course is the difference between a parameter and a statistic. And when you talk about parameters, you should always think of populations, because a population is the collection from which you calculate numerical measurements that are called parameters. If you're thinking about a statistic, which is probably the term you hear most often, you're always referring to a calculation that is coming from a sample. So we are going to spend most of our time with samples and then try to use those samples to make inferences about the population. If we had the population data, we'd simply not worry about inferences and we could actually tell the exact values for the population. But most of the time you have samples and therefore need statistics to make inferences about populations. There are different categories of data we should be familiar with. Quantitative, meaning numerical, data such as sports scores. So all sports tend to deal in numerical data. You can count the number of items. You can look at stock market numbers. So most things that you look at are probably numerical in nature. But then you also have qualitative data, and qualitative data is associated with colors. Things that can't be listed in a particular order, but they simply talk about some type of quality associated with the elements that you're examining. Two categories that are relatively subtle that sometimes can miss. Discrete data is data that again can be countable and it can be matched up with integers. So there should be either a finite number or a countable number of possibilities. So when I'm looking at counts of numbers of people, or if I'm looking at any type of count, then you're usually talking about discrete data. And if I'm talking about continuous data, I'm talking about no gaps, measurements in which every two numbers has infinitely many numbers between them. And examples of continuous data would be temperatures and also heights, because any two heights that you measure, you could find a height between those two. So remember, continuous is no gaps, discrete, there's gaps between the data. Now if you look at the different categories of data, we have data that is nominal in nature, meaning it has no number associated with it, it's simply qualitative only. And nominal data would be things like listing the brightness of a particular outfit, or if I looked at a style and whether I liked a certain style. Ordinal, on the other hand, is data that is specifically associated with quantities, but when you look at the computational differences, those differences are meaningless. Meaning if you rank bands and you list the top band and the second band and the third band and the fourth band, the difference between the second and the third band is not necessarily the same as the difference between the third and the fourth band. All three of the top bands may be relatively the same, and the fourth band may be much worse. So the differences do not necessarily reveal information about the items that are being ranked. Now, interval data and ratio data are also quantitative in nature, but they have a higher level, meaning there's more things that are specific or more characteristics that you can identify about this data. In particular, interval level data not only is ordinal, but it also has meaning behind the computational differences. For example, if you looked at temperatures, you can see that there's a difference between 32 degrees in Chicago and 70 degrees here in Moore Park. So that difference not only tells you that the Moore Park temperature is larger, but it also tells you how much larger. And there's significance to that difference. But there is no zero associated with temperature, meaning even if you go to zero, you could go below zero for temperatures. So there is no absolute starting point. Whereas ratio level data goes one step further and not only has this meaning behind the differences, but it also has a starting point So if you're doing times for races, you'll see that times for races not only have meaningful differences. If you race 3 minutes faster or 5 minutes faster, that tells you how much faster that person was, but it also has an absolute zero. There is nothing smaller than a time of 0, so that's your absolute starting point, and therefore times for races would be ratio level data.